Okay, in this video I'm just going to do a bit of an extension on the hyperbola. So we're actually looking at what's called the inverse proportion graph. Okay, it's another word for the hyperbola. So to illustrate this, we're going to consider the time taken to travel a fixed distance of 60 k's. So the um, time to travel a fixed distance depends on the speed of travel. So for a distance of 60 k's, the time taken for some different speeds are going to be shown. Okay, so we've got speed and we've got time. Okay, we've got speed of 10, 15, 20, 30. Okay, what happens at the time? Well, we've actually given some time, so we've actually got 6, 4, 3, and 2. So as the speed increases, the time will decrease. So as the speed decreases, the time will increase. Okay, proportion or opposites of each other. So we can say the time is inversely proportional to the speed, or that the time varies inversely as the speed. So from the table, we can say our time times our speed, which is v, for those that do physics, stands for velocity. Okay, we're just calling it speed for now. Okay, and so therefore we can say our time is actually 60 over our speed. Okay, why is that? If you remember in science, you have the triangle. Speed is distance over time. Okay, our distance is 60 over our time. So that's where that comes from. Speed equals distance over time. Time equals distance over speed. Distance over speed. So now we're formulating it in mathematical terms as a formula. So to represent this on a graph, okay, we only want the positive values. Time being positive, speed being positive. So we say 2, 0, 2, 4, 6, 8, and 10. And our speed is going to be intervals of 5. Alright, put our points in. Okay, at 10, our time is 8. At 10, it's 6. So we've got the point there. At 15, it's 4. So point there. At 20, it's 3. So halfway between them. And at 30, we've got 2. Now, you can kind of see a shape forming. And if we had a 5, it's going to be somewhere up here at 12, I would assume. So we actually get this graph that we've just done. Okay, so as we go along the x values, we get closer and closer to the x axis, which is where our horizontal lies. So at 60, what happens at 60? Put that in. Our velocity is 60. 60 over 60 is going to be 1. So we get 60 and 1. And here's our other points. I'm not going to label them. So in general, you can say the following rules. Y is inversely proportional to x. And we actually write that as y, and a little funny symbol looks like that. Inversely proportional to x. A second point, if y is inversely proportional to x, then y equals K on X, where K is a constant of proportionality. Okay, so we're proportional in some constant. So in this case, we've got 60 would be our K. Okay, that's because we've dilated it. So this relationship can also be expressed as xy equals K. Okay, that comes from that point there. Okay, our time times velocity gave us our distance. So if the product of two variables is constant, the variables are in inverse proportion. So inverse proportionality is those examples. Now I'll just go through example 9. I won't write it all out, but if you have a look on page 285. So we've got Boyle's law. For those that do chemistry, that is, if the temperature of a given mass of gas remains constant, its volume is inversely proportional to the pressure. P. A container of volume 100 centimeters cubed is filled with gas under a pressure 75 centimeters of mercury. Find the relationship between the volume and the pressure. So again, let's start with our inverse proportion relation. So our volume is inversely proportional to our pressure. Okay, therefore we can say that V has the relationship K over P. Okay, where K is going to be some constant. Now, we use the given data to find the K, and hence we find the rule. So, substitute our value, V equals 50. Okay, in the example, they've actually got a typo somewhere, by the looks of it. Okay, so we should actually have our volume, which is 100, not 50. So just subbing in those values, 100 equals K and over 75. So what's K equal to? That would be 7,500. Okay, pretty straightforward, just sub in the values. So what we can say now is, from that, our V is actually 7,500 over P. Now, part B says the container is connected by a hose to an empty container of volume 50. Find the pressure of the two containers. So, the two containers are connected and can be thought of as one. Okay, because we're connecting them, the combined volume is therefore going to be our initial, which was 100, plus our 50 for our question. So our total volume is 100 plus 50, which is 150. So now we can calculate the pressure for this volume. So we know our volume formula, which is up here, and we now know that it's actually our V is 150 for this example. So we're just solving for P now. So just subbing in 150 for V. Now times by P, divide by 150, or we just swap the values. We can say P equals 7,500 over 150. Okay, crossing the numbers, we get P equals 750 over 15, and that is 50. So, the gas in the container is under pressure of 50 centimeters of mercury. Again, there's an inconsistency with the textbook. they've made a mistake somewhere. But that's for our answer, what it should be. Yep, so just a bit of an extension on proportionality. So I'll leave that there. So that's pretty much chapter 6.4. Have a go at the questions and we'll have a look at the next chapter shortly. Thanks.